that we're doing this year, so focus. Okay. Quadrilaterals is this chapter. We're going to start with just talking about angles of polygons. So what we have up here is a chart. Okay. So triangle, quadrilateral, pentagon, hexagon, heptagon, octagon. We should already know those words. We've talked about those this year. So if I say a hexagon, you should know how many sides it has. 6. How about an octagon? How about a decagon? 10. Okay, good. All right, so that's all these first two columns are saying. Is it saying the triangle has 3 sides, which we all know. Quadrilateral has 4 sides. We know that. Pentagon, 5. Hexagon, 6. Heptagon, 7. Octagon, 8.
That's how we're doing today.
We're figuring out the sum of the interior angles today. So what we're going to do is we're going to break all these shapes down into triangles. So a triangle has just one triangle inside of it. Okay? How many degrees are in a triangle?
How many what?
180. If you stop talking while I'm teaching, you wouldn't have to re-ask a question. Okay? So there's 180 degrees in a triangle. There's one triangle, so 1 times 180 is 180. Okay? In a quadrilateral, so there's a quadrilateral. We can break this up into 2 triangles by just drawing a diagonal in. And now see that we have 2 triangles. So there are 2 triangles in a quadrilateral. Each triangle has 180 degrees. So 2 times 180 is 360.
And that's all you do for all of them?
That's what we're doing right now, yes. A pentagon is 5 sides. How many triangles do you think we have in a pentagon? Yeah, we have 3. We can draw those 2 lines. We have 1, 2, 3 triangles. So we could take 3 times 180. Well, what's 3 times 180? 540. Hexagon. How many triangles?
4.
4. Now, how did you get 4?
Because it just goes up.
Yeah, you're looking at the pattern here, right? It goes up every time. All right, so if there's 4 triangles and 180 degrees in each, yep, 720 degrees.
But the next one's 900.
In a heptagon, there's 7 sides. So how many triangles? 5. So to get the total degrees, what would we do? Yep, 5 times 180. 900 degrees, yep. Okay. Octagon has 8 sides, so how many triangles?
6.
6. So over here, to get the total degrees, we have 6 times 180, which would be what? 1080. Now, there's actually a formula we can use. Focus, please, on what's going on. Not talking across the classroom, okay? Focusing on up here. There's actually a formula we can use to find this. Instead of creating a whole chart and then counting down to like a 20 gone, we can think of a formula. So what I want you to notice is I want you to pay attention to the number of sides and the number of triangles for each of these rows. And do you see something that's consistent? It's always 2 less. Okay, so the number of sides to the number of triangles we're subtracting 2 every time. Now, that's going to work the whole time. Okay, so we have a formula then that would help us find it. We have to subtract 2 from our number of sides, and then we times it by 180. So our interior angle sum theorem, that's what it says. If a convex polygon has n sides, and if S is the sum, then the sum is equal to 180 times n minus 2, which is exactly what our chart was doing. Okay? We were multiplying our 180 by the number of triangles, and we got the number of triangles by taking the sides and subtracting 2 from it. All right, is that okay? All right, so now the next one, the exterior angle sum theorem, says if a polygon is convex, there goes the book. If the polygon is a convex, the sum of the measures of the exterior angles is 360. So what do you think the exterior angles are? Where are they? Where are the exterior angles? On the outside. So if we look here, those would all be exterior angles. So if we add all those up, it's going to equal 360. Okay, we can do the same thing for our quadrilateral. We have all these exterior angles. If we add those up, it equals 360. It doesn't matter how many sides we have. Okay, so even if we have 20 sides, if we add up all the exterior angles, it equals 360 every time. So now we're going to use this information to find some angles, either the interiors or the exteriors. So number one, we want to find the sum of the interior angles of a 21 gon. So how are we going to do that?
21 times 19.
Not 21 times 19.
19 times 180.
It's 180 times n minus 2. Oh, that's 0.
So subtract 21.
So 21 minus 2 is 19. And then times it by 180. Okay, so what's 180 times 19?
3420.
Genius. Even though I used to calculate.
Okay, so that's 3,420 degrees. Okay, so now we're going to work backwards. So I'm going to tell you what one of the measures of the angle is, and we need to figure out how many sides. Okay, so the measure of an interior angle of a regular polygon is 108 degrees. We want to find the number of sides. Not quite. So we're going to focus on what this formula is. What does n stand for? So that's what we want to find. So we're going to leave the right-hand side of this formula alone. We need to think about what the sum would be. So if each angle is 108 degrees, how would we find the sum of angles using that 108?
Well,
We'd have to multiply it by how many angles there are, right? Does the number of angles in a polygon and the number of sides, is that the same number?
No.
So if it has 4 sides, does it have 4 angles? 3 sides has 3 angles. So here, instead of the sum, we can rewrite it as 108 times n, times the number of sides. Because that would also give us the total sum. And then we could solve this for n. So to solve this for n, we got to get n all on one side. So what should we do with this 180?
subtract it.
Can't subtract it because it's attached with multiplication.
Then you would have to divide it.
Oh. What else could we do with it since it's in front of a parentheses?
Move everything over there.
Distribute.
Still have to divide it.
So 108n is equal to 180n minus 180 times 2, 360.
That was still right.
Now how could we get the n's together?
Subtract it.
Now we would subtract it.
Still right. You still got to divide too.
Yeah, but not by 180.
So technically,
108 minus 180, what is that?
negative.
Yep, negative 72n is equal to negative 360.
Now you
And then divide it by negative 72. So what is our n? Yep, positive something. What is it?
12.
James, what are you getting?
I got 5.
5. Okay.
Didn't work.
5 sides. All right. What would happen if we got a decimal there? What would that tell us? We did something wrong. Okay. We need to get a whole number here because we're talking about the number of sides.
So you wouldn't just round it?
No, we would not just round it. You did something wrong if you got a decimal. Let's try the next one.
Are you telling me that we're going to do something wrong in the next one?
No. The measures of the interior angle of a regular polygon is 135 degrees. Find the number of sides. So how are we going to set this equation up?
Like you did with the last one.
Okay, so instead of S, what would we have?
135.
135 what? N.
Equals 180. Parentheses n minus 2.
Okay, so we have 135n equals 180 times n minus 2. So we distribute, so 135n. So 180n minus 360. Okay, minus 180n.
Negative 45.
So we have negative 45n is equal to negative 360. I was holding it backwards, so I kept touching the button. So then what do we do? Yep, divide by negative 45. So negative 360 divided by negative 45 is what?
8 sides.
8 sides.
Yep, that's correct.
Is that okay? Make sense? All right, there are some other types of problems that we will also see. Now we want to find the measure of an exterior and interior angle of a convex regular octagon. So what that means is that we want to find what the angle measure of each interior angle is and what each exterior angle is. So we're going to start with the interior ones first. So to do this, we can first find the sum of all the angle measures first. Okay, if we find the sum of all the angle measures, what can we do with that to find what each angle is equal to?
8 and then take whatever.
Yeah, just divide by your 8. Okay, so the sum is 180 times n minus 2. This is an octagon, so we have 8 sides. So what would we have to times 180 by? Not 8. By n minus 2. What would be 8 minus 2? 6. Okay, what's 180 times 6?
680.
No. It's 1,080.
I was close.
No, you were not. Now, that's the sum. Okay. Some of you, clearly, have already thought that the year's over. It's not. Get it together and focus. Okay?
We hit mid-quarter.
All right?
Mid-quarter today.
Your mid-quarter grades are after your get your test grades in there. So some of your mid-quarter grades might be pretty terrible. Okay? So focus on what's going on right now and not all these side conversations. Got it? We'll do a new seating chart as well. Okay. So if this is the sum of all the angles, how would we figure out what each angle is?
You have to 1,080 divided by 8.
Yeah, we just have to divide it by 8.
Why would you divide it by 8?
Because there are 8 sides.
Okay.
So 1080 divided by 8, what does that equal?
135.
So that is our interior angle. Yep. Now, we now also have to find the exterior angle. There's going to be two ways that we can do this. The first option is that our exterior angle sum theorem told us that no matter how many sides we have, all the exterior angles add to be 360. So if all of the exterior angles add to be 360, we could take our 360 and just divide it by 8. That would give it to us. So what would be 360 divided by 8? So 45 degrees is our exterior. Okay, that's one way how we can get it. No matter what type of polygon we have, the exterior angles always add to give you 360. Doesn't matter how many sides you have. The second option that you can do is your interior angle. So here's our octagon. So here's our interior angle. And our exterior angle have to add to be 180. So you could also do 180 minus the 135 and get your 45 as well that way. Okay, so either way works. All right, let's do one more. Find the exterior and interior angles of a regular nonagon. Okay, nonagon has 9 sides. So what are we going to find first, interior or exterior? Interior? So how are we going to find it? Okay, so the sum times 180 times n minus 2. So what's 9 minus 2? 7. So we have to take 180 times 7.
I got this. Daniel, stop. Stop. Don't do it.
12.
Oh my gosh.
1,260 degrees. Now, divide it by what? Divide it by 9 because it says 9 sides. So 140 degrees is the interior angle. So then what's the exterior? 40. Now how did you get that so quick? Yeah, so we can just think in our head, we can subtract it from 180 to get 40. What's our other way we can get our 40? We could also do 360 divided by 9 to get 40. Right, in this case, if we just think 180 minus 140, that's pretty simple to do.
So to get the exterior, you're always going to take it by whatever the number of sides is.
Yep. Yep. Could you find the exterior angle first and then get the interior?
Yep.
Sure. Doesn't matter which one you find first. For exterior, it's always 360. Okay?